Today we're going to talk about residuals. Now, basically, if you have a scatter plot similar to what I have on the screen, we have a line of best fit, which is the best fit for my data values. And if you notice, some of the points are above and some of the points are below, which is not always the case at every line of best fit, but in this case it is. Now, when you're talking about a residual is the distance between the actual point on the graph, so I'm going to choose this one over here. But the actual point on the graph, the distance it is from the estimated line, or the predicted line is what they call it. So that distance between those points, that's basically called the residual. Okay, so kind of like from this point to this point, there's your residual, and there's a residual. And residuals are looking at all of those distances. Now I'm not going to draw every single one, but residual is the distance between the actual value, so the actual value is the actual data point, and the predicted, which is from the line of best fit. So for a residual is actually actual minus the predicted. Okay. Now, when I'm talking about actual, again, actual just means it's a point on the graph. So, an actual point sometimes it doesn't register when I write something on there. But the actual is the actual point on the graph. So if I'm looking at this graph on the screen, it's all those black dots. Those are the actual points. Predicted is basically comes from the line of best fit. Comes from the line of best fit. Okay. Now, an easy way to remember how to find a residual is equal to the actual minus predicted. Now, if you look at the order in which those are, it spells out R-A-P. So one way you can remember the order of that is thinking of RAP. Residual is actual minus predicted, so it's going to be the same order as RAP. So what we're going to do with residuals is I'm going to give you basically a line of best fit, and I'll give you data values, and we're going to determine some of our residuals to it. So if you need something from this page, go ahead and pause your screen and jot it down. I'm going to clear it off. Okay, so let's say, for instance, I'm just going to make a table. Let's say number of people, and let's say the cost of something. So let's say there's 5 people and it's going to cost us 20. Let's say I have 6 people, it's going to cost us 23. Let's say 7 is going to cost us 27. Let's say 8 is going to cost us, that isn't 8 by the way, that doesn't quite look like it. Let's say that's going to cost us 31. Alright, so let's say if we want to find the residual, we're going to find the residual. Of 7 people. Okay. So, again, if we're finding residual, residual we know is going to be the actual minus the predicted. So, our residual is the actual minus predicted. So, in order to find our residual, sorry, I had to pause for my children again. So again, residual is actual minus predicted. The actual is the one that's our actual data value. So we actually already have the actual. We know we're looking for 7 people, which happens to be here. So the actual for 7 people, the actual is 27. So in this case, 27 is our actual. So we already have that part of it. So the actual comes from the table of values. It can come from the graph, depending on how the information is given to you. But we have the actual now. We just have to be able to figure out our predicted. Now the predicted comes from your line of best fit. So we're going to have to go in and take this table and get our line of best fit. So we're going to go to Stat, Edit, And if you have other data, if you highlight the top, hit clear and down, and we'll clear it out. So I'm putting my x's in L1, which would be 5, 6, 7, and 8. And I'm putting my y values in L2, which would be 20, 23, 27, and 31. So we've already practiced finding the line of best fit, so that's something you should be pretty good at. So calculate, so stat, calculate, we're going to go to number 4, which is our lin reg. You hit enter, so you see your function. So mine, I get an equation, I get an a value of 3.7 and a b value of 1.2. So my line of best fit So my line of best fit in this case would be y equals, I have an a value of 3.7, so 3.7x, and I have a b value of 1.2. Okay, so in order to find our predicted, basically we want to plug in the value for x that we're dealing with. Well, the value for x that we're dealing with is 7 people. So we're going to basically plug in 7 in for x into our line of best fit. When we looked at our table, for 7, we got our actual of 27. Now we want to use the line of best fit for 7. The line of best fit for 7 means I'm going to plug in 7 in for x. So all I have to do is 3.7 times 7 plus 1.2. And that will give me my predicted value. So that's something we can just do right in the calculator. So 3.7 times 7 plus 1.2 is going to give me a value of 27.1. So that's my predicted value, 27.1. So again, my residual is going to be 27 minus 27.1, which is going to be a negative 0.1. So my residual, in this case, is negative 0.1. That is my answer to it. So in order to find the residual, it's your actual minus predicted. The actual is easy. The actual comes from the table or the graph or whatever it is that you're doing. In order to find your predicted, though, you have to plug in, we have to find our line of best fit and then plug in whatever it is we're looking at in for x and solve. And then just calculate that final part, and that is our residual. So I'm going to look at another example. So if you need anything from this screen, go ahead and get it. I'm going to clear it off. Alright, so let's do an example where we have, let's say, a graph of values. So I'm going to pick a couple points, and let's say this one's at 2, 11. I'm going to say this one's going to be at 4, 15. I'm going to say this one's going to be at 5, 13. And I'm going to pick another value and say this one is at 7, I don't know, 16. Again, I'm just making this up. Now, let's say we want to find the residual. And the residual for, I'm going to say the x equals 4. So I'm going to happen to pick that one. Well, again, residual is your actual minus your predicted. So we already have the actual. When my x is 4, my actual that goes with it is 15. So I know the actual. Now I just got to find the predicted. So again, to find the predicted, I'm going to have to go in my calculator. I'm going to have to calculate my line of best fit. So again, x is in L1, y is in L2. So our x's in this case, so in your calculator, x is 2, 4, 5, and 7. So my x's again are 2, 4, 5, and 7. My y values, I'll pick a different color, let's go with purple. My y values are 11, 15, 13, and 16. Just make sure that when you type them in your calculator, the 2 has to go with the 11, the 4 has to go with the 15, and the 5 has to go with the 13, and the 7 goes with 16. So just make sure you're careful. Some people write out the table first before they ever type in their calculator. It just makes it easier for them. Some people just type it right from looking at the graph. But either way, we have our x's in L1, our y's in L2. So we go to stat, calculate. Number 4, which is our lin reg. And for mine, I get my line of best fit, I get y equals 0.88, and my b value is 9.769. I'm just going to say 9.77. Okay, usually rounding 2 or 3 decimal places is usually good. Alright, so now we want to go through and we're going to find our predicted value. So again, whatever it is that you're looking for, in this case we're looking for that x is equal to 4. So we're basically going to plug in 4 and for x into that function. So I get y is equal to 0.88 times 4 plus 9.77. And again, we just kind of type that in our calculator. So 0.88 times 4 plus 9.77. I get 13.29. Okay, so there is my predicted value. So over here for predicted, it's going to be 13.29. Okay, so again, your residual is your actual minus predicted. Actual we were looking at was when our x was 4. When our x was at 4, our actual value was 15. If I do my line of best fit, I get my predicted value was 13.29. So in order to find my residual, I just have to subtract the two. So I do 15 minus 13.29, and I get my residual is 1.71.